Okay, so picking up from where we left off in the last class, where we've completed 90% of the floor plan, in this tutorial we're going to turn the floor plan into a section, and then the sections are going to inform us of the elevations. So before we get started, let's just finish off the floor plan, and we really only have one more element to draw on the floor plan before we start annotating, and they are the stairs. So we're going to use, in this session, we're going to use a lot more of the generic pen layers. And really what pen layers are, you can see them here, A pen 09, A pen 25. And we're going to create another 2 or 3 before the session's finished. And these really are layers for items that you don't really have anywhere else to put them. So if it's not a wall or if it's not a door and you don't want to make a layer for, absolutely every item, which you don't normally do, you just associate them with a pen layer. So we're going to start off first of all by using the pen 9 layer. And I'm going to use a polyline. And I'm just going to draw these stairs just as a rectangle. Now I'm drawing these stairs the same width of the door and 250 mil deep, because that's the minimum standard for a stair tread. And then I'm going to copy that stair, and that's now done. Now I'll draw the arrow for that stair, starting at the midpoint from the bottom of the stair to the top of the stair. And then what I'm going to do is I'm going to draw a line on a 45-degree angle at, say, 150 mil. Hit escape, mirror that across, and that's our stair arrow. Now we want to convert these though to a much thicker line, to a 0.5 line. So first layer we'll make today will be A-pen-50. That's a blue layer with a line weight of 0.5, half a millimeter. So now it's complete. I can assign layers, or I can assign objects within the CAD file to layers after I've drawn them. So I can select these 2 lines, go up to the drop-down box, click on A-pen-50, and they'll convert into the A-pen-50 layer. So the floor plan is now complete, the 99.9% of it. Next up, we're going to look at the section. So we'll draw the section line first so we understand where the section has been cut, and then we'll group this, copy it across, rotate it, and then start drawing a bunch of reference planes to help inform us of the basic structure. So when we look at the example set, we can see here these section markers are going through the window. We're going to draw our section marker basically at the halfway point, the midpoint of the window, going straight across. And the way to read these section markers is the arrowhead on the section marker itself defines that we are looking to the right, in the direction of that arrow. So that's the direction that we're looking in. And then the A and the dash, each drawing set might be slightly different, but what that's referring to is we're looking at drawing A, and then the dash means that it's on the same sheet that we're currently looking at. If this was on another sheet, we would see 02, 03, or whatever that sheet number might be. Also, it may not always be called section A or section B. Sometimes it's called section AA, section BB, or sometimes it could be, just might be 01, or it could be 43 for all we know. There could be 43 sections. And we can see that because section A is here, it's denoted here, and it's on the same sheet as this drawing. So there's no need to reference the sheet number. So let's go back to CAD, and I'm just going to draw, I might draw with the 50. The A-pen-50 layer, just a line from the middle of the window upwards, like so. And I'll just move this down. So that line defines where the section marker is. So I'm going to take the entire drawing and just copy it and move it across. And I'm now going to take this and group it by just typing in the command group. Okay, so that's now grouped. I'm going to rotate this 90 degrees. Perfect. I'll just move this somewhere around here. And I'm going to go back to my reference planes layer. And we're going to start drawing these reference planes across. So that's going to be my ground line for no other reason other than just, I'll put a line somewhere. But we'll start with these reference planes up. So we're going to go take the external faces of either wall. We want the center line because that will inform us the center of the roof. We want the eave lines, like so. And then we also want to take elevation levels. So I just drew this first line here, which is just generically the ground line. And then we need to work out our additional heights. So we need the finished floor level. When you see FFL, that stands for finished floor level. NGL stands for natural ground level, by the way. CL stands for ceiling level. Or sometimes you might just see on drawings RL, and RL is just denoted everywhere, no matter what that is. And that is known as reduced level or relative level. It just means it's relative to wherever the datum point is for the site. So the distance between this point and this point we'll call 460 mil, and then the point between here, the ceiling line, and the finished floor level will be 2.4 meters. Let's go back to CAD and we'll just use the simple offset. So 460 up, that gives us the finish floor level. And then offset that again, 2.4 meters. And that gives us our ceiling level. That is more than enough now to start working on this section. The other tip that I have for you is that we will work on half of the section and then just mirror it. So we'll work basically on this side and not touch this side. Because what we'll do is once we construct this, we'll just flip it, we'll mirror it, and then we already have the other side built. Besides the fact that it is just purely quicker to draft this way, it also helps reduce the risk of drafting inconsistencies or simply detailing incorrect. It means that you can work out the first one, the first detail, or the first construction method, and then just copy it across without needing to worry about whether you're doing it correctly the second time. Okay, so we're going to use, again, a bunch of pen layers. But before we get started, I want to make a timber stud block. So that is relatively easy, but we're going to need to create another layer. So I'm going to go here, create another layer, and we're going to create a pen 35. And as the name implies, that's a 35 line weight, 0.35. I'll make that green. Oops. Okay, and I'll just make a polyline that's 90 by 45. All right, and then the crosshairs I'll just use with a pen 9. Done. I'll take this and I'll block this up, and I'll call this timber stud underscore 90x 45 millimeters. Pick a point. I'll pick this bottom corner here, and that's now completed. Okay, and in fact I might just move this to this bottom corner. Alright, so I'm going to take another layer we need to create, which is a pen 18. So at the end of this we'll have pen 9, 18, 25, 35, 50, and then we'll create another one for a pen 70, which will be our thick ground floor, like our thick ground line. The ground line's always the thickest line. So another layer. Okay, polyline. Oh, I'll make sure I'm on that layer. Okay, so that is our stud wall on the left-hand side straight away. So we've taken it from this guideline that shows us the outside face of this wall, and then we've drawn the stud wall going up. I can then take this stud and I'll copy this to the top. So there'll be there's a double top plate on this stud wall, 1 and 2. All right. Next up is the roof truss. So the easiest way to draw the roof truss is we're just going to draw just a straight line, and then we're going to rotate this 22 degrees. That will give us just a random line here at some generic length we won't know. But the important position that we want to start this truss is this point here. It's the point where the truss meets the top of the stud wall, and where the bottom chord of the truss meets the top of the top plates. And so just as a reminder for standard sort of truss terminology, we've got a standard truss here where these two lines, this denotes this zone here, that is the bottom chord of the truss. This here on the angle is the top chord of the truss, and then this in here, this infill, this is known as like your truss webbing. So going back to here, I'm just going to draw just a generic line straight across. And then I'm going to type in rotate. I'll rotate from the center and then type in 22. So that's now rotated 22 degrees. I'll take that, and I'll even just take the midpoint again. And I'll align it endpoint just there. Now we're just going to use the offset command to actually fill out our truss. So offset 90 mil, because they're all 90 mil elements upwards. And then I'll draw another line from this point to the midpoint of the building, and also offset that 90 mil up. Okay, so you can start to see the idea of how we're getting this truss shape. And then these reference planes actually act as our guides when we want to trim these back. Next up is the webbing. And the webbing is the same thing, but on another 22 degrees in the opposite direction. So again, I'll just draw a shorter line this time. Rotate it 22 degrees. But then I'm going to mirror it because we're working in the opposite direction. And I will erase the source object in this instance. So I'll hit Y on the keyboard and then enter. I'll take that, and I'll take the end point of this line and put it at the end point just here. I'll then offset that 90 degrees, like so. And because this is the center point of the building, or the center line of the building, I want to draw a line from here to here for my central webbing, but then I only want to offset that 45 because the other 45 on the other side gives us the 90. And I'll delete that. So that's now complete. We can start trimming back this whole roof truss. So I'll use the trim command. I'm just going to select every element and just start slicing away. Cool, excellent, done. All right, now what we need to do is we need to draw our roof battens, which are these elements just here. And we're going to use the array tool for this. So I'm just going to grab one of these studs, copy them, and I'm just going to put them right there. And then we'll rotate this stud. So I can just type in rotate, click a base point on the stud and type in 22 degrees. The other way we could rotate when you need a reference, so let's say we didn't know what the angle of this line was. The other way to do is to select it, hit rotate, click one of the base points, so click the corner, and then hover your mouse over an intersection where the two lines meet, and you'll see that will give us the same angle. It will follow that path. So that's very helpful. I'll then take this stud, and what I'm going to do is I'm going to move this all the way to the base of the truss, back to here, and then I'm going to move this up, basically 90 mil, like one truss length. Okay, so we're starting 90 mil from the edge of the truss. I'm then going to use the command called array, and it's going to give us three options. So arraying essentially just means, copying elements and grouping them in some sort of direction. So the first option, rectangular, is pretty self-explanatory. It will just array it in some sort of rectangular grid. You can define how many columns or how many rows. and the distance between them. The next one is path. That's the one we're using because we're going to use the top line of the top chord of the truss as the path that this will be arrayed along. So it will basically go from the start of the line to the end of that line. And then the third option is polar. And what polar is that allows you to take like a circular path around some sort of center point. So if I was to do polar, it would essentially take this point where this current block is and then array them in a circular motion around it. So we'll take the second option, which is path. That's fine. And then you got to select the path. So I select this line as my path, and you can see now that it's arrayed them along that line. So the distance, the length of this line is what, 2.48 meters. The distance between this first line here and the last line is also 2.48. That's why it's slightly overhanging, because I'm starting 90 mil into this line. Either way, that doesn't really matter. If your array is facing the other way and all these array elements are facing downwards, the best thing to do is just hit escape and then rotate the block that's sitting here 180 degrees, basically flip the object, and then it will array in the other direction. Okay, so once I select the array, a new tab appears called array, and then the ribbon changes for all of the, the customization you can do to that array. Pretty simply, I'm going to change the distance between these to being 450 mil, which gives us something that looks like this. That's perfect. Hit escape. Now that's done. We're going to draw another line on top of this, which will define the roof material, and we're just going to use one thicker line. We're not going to draw two thin lines, just one thicker line. So I'll take a line, and this time I'm going to use pen 25, and I'm just going to draw from the top all the way down to the bottom. And you'll notice that I didn't get to the center point, so I might just use the extend command. This is where I want to extend to, and that's what I want to extend. All right, almost there. Next up, we're going to draw the fascia board, and the fascia board will go on the edge of the truss here, and I'm going to use the same line weights that we used to create the timber stud. So polyline, I'll start here, and I'm going to go down 200 mil and then across 25 mil, back up 200, done. And now I'll just do the crisscross with pen layer 9. And the reason why I'm not going to block these is because it really only occurs twice. This section only appears on one side and the other, and that's basically it. Whether you compare that to the timber stud block, you know, we've got at least half a dozen instances here, and it's going to immediately double once we flip this over. So the frequency that we use that is just much greater. All right, so we're now complete with the roof structure, but let's think about the footing detail. So again, the footing detail I'm going to do once here and then mirror that across. The flooring itself I'm going to draw as one object because I don't want to have some sort of break split line in between. I just want to draw it as one continuous line. So I'm going to use polyline, go back to my pen 18 layer, and I'll start here, draw down 18 mil, come across all the way to the other side, up and around. So that's one completed polyline, like so. I'm then going to draw another polyline, which will be 90 mil thick. So 90 mil down and across. And what these are the floor joists that sit underneath the particle board, the tongue and groove. And you'll see that I'm completing the loop there too. So I've basically traced over this bottom line. But that's important though, because if at any point you need to hide one of these elements, like let's say I wanted to hide the tongue and groove flooring, I still want to see the top line of the joist underneath. If this wasn't a completed polyline, you wouldn't see that line there, and that would be, it just wouldn't be, you know, drafting manner, it wouldn't be correct. And just layering the same if you've got two lines over the top of each other and they're on the same line weight, it's just not going to matter. It doesn't matter at all. If there's two different line weights, it's always going to take the thicker line weight. That's why here with this timber stud, even though I've drawn the stud wall around it, it doesn't really matter because the pen 3.5 is thicker. It's going to go over the top of the pen 1.8. All right, so I'm going to take this stud, copy it, rotate it 90 degrees, and I'll take that and just put it here. All right, so what we're doing now is we're drawing this footing. Now this footing is exactly the same as this footing over here, just that the bearer is left justified here and it's right justified here, which will work when we mirror it, and you'll see the center one is actually center justified. That's the only one that we would have to amend, but we'll just copy that across. So I'm going to use pen 18 still, start here, come across. The stumps are 100 mil by 850 mil deep. Okay, that's done. And then I'm going to use a pen 9 to draw my excavation zone. So I'll start here at the point where the ground line meets, and I'm going to come out 100 mil. I'm then going to go down 800, across 300, and then back up. And then finally we need our pad footing, our concrete pad footing, which is 50 mil above the bottom of the stump. So I hold my mouse over the bottom of the stump, the end point, and just move my hand up and type in 50. That then gives me the starting point for this line. Done. Okay, so we can take all of this now, and we can flip this over to the other side. So I'm just going to select all of this, mirror. It can be anywhere from this midpoint or this midline. Click. No, that's now complete. And for the center stump, I can just copy this whole thing across. And then I just have to move these items to be center with the bearer. Done. Now, if I hide the reference planes, you can see we've got the pretty good bones of our section. All right. So next up is hatching. Down here, the earth fill and the hatching. So what I'll do is I'm going to take a polyline, and I need to draw like the extents of the earth. So I'll start from the center, and I'll come out this way, and I'll go 4, 4, 5, 0. Enter. I'll then come down 1 meter, back to the center, and then I'll click again. So from the center out to the left, it's 3150. Up and then back to the center. And that's now like our earth hatch zone. So when we go to the finished example, it's this zone just here that we've drawn. Okay. Now the way hatching works is hatches in AutoCAD are basically patterns. That's all they are. And they work by finding the boundary of lines and putting a hatch or putting a pattern within that boundary. That's why even here you'll see when you use the hatch command, it's looking for these lines here, because what it does, it then fills up anything within that space provided my mouse is hovering over this area. And likewise for these areas here and the earth hatch. That's why we have to draw this boundary here, because otherwise AutoCAD wouldn't know where to stop hatching. A good tip for you though is make sure that your lines or your boundaries are closed. If we had a box that looked like this and it was open just here, what would happen is AutoCAD wouldn't understand that this was the area I wanted to hatch. It would see that area is open and think, oh, okay, you want to hatch the whole drawing. And that will immediately crash your file, undoubtedly. So you have to be very careful that your polylines are closed. And the other thing too is a good tip for you before using hatch, always save your file. Save your file before you start hatching. The other thing to note is that in the elevations, these lines here that make up the tin roof and these lines here that make up the weatherboards, these are not individual lines. They are hatches that are just, normal lines that are rotated 90 degrees, set a certain distance apart. That's it. All right. So now in CAD, we've got all our zones for hatches. What I'm going to do is I'm going to hide the reference planes, because every time a line intersects a zone, AutoCAD will want to hatch it as two different zones. So because we had those guidelines coming through here, you would end up with multiple zones for earth hatching when really that's not necessary. So I'm going to go to my hatch layer, which has already been created. AN stands for annotation hatch. All right, and I'll type in hatch on the keyboard. And another good tip for you is just start clicking straight away into zones. So I'm just going to click in this zone and in this zone, because they're going to be the same hatch. It's going to be that backfill hatch, and the same thing in these stumps as well. So however many times I click within this one command, once I hit escape, you'll see that all 3 of those stumps or 6 of those zones select as one object. It's always much safer just to select the elements you want, hit escape, then come back and click on them to then edit them. Because once you click on them, a new tab appears called Hatch Editor, and then the ribbon turns into all these commands that you can edit the hatch with. Much easier to do it that way. Otherwise, if you try and change it on the fly as you're hatching, again, AutoCAD tends to crash. It's just a characteristic that's always been there. All right, I'll do the concrete zone as well. So the concrete zone for these pads, and even though, see, it looks like it's the same hatch, well, in fact, it is the same because I haven't edited the first one. Once I hit escape, you'll see they're 2 different zones. I can give them 2 different types of hatches, which I'll do now. So for the concrete, or actually for the backfill, I'll click on these zones. I'm going to take just an angular line pattern. And really the 3 commands or the 3 options you're going to use is the first one, which is the transparency of the hatch. Second one is the angle of the lines or the pattern. And the third one is the scale. So firstly, in terms of the hatch transparency, I might leave it at 20% transparent. So it's relatively defined, but not overly powerful. Second one is the angle. I'm happy with the 45-degree angle, so I'll leave that at 0. And the scale, I might type in 10. So it's just a scaling factor. So it's 10% or 10 times the size of the default hatch. And you can see that's now updated the other ones as well. Now with the concrete, I can click on this little drop down arrow here and it brings up all the different patterns that are available in CAD, including architectural concrete. The scaling works in the opposite direction too. So I'm going to change this scale, transparency back to 20. And the scale, instead of being 1, I'm going to say it's double the density. So I'll make it 0.5, hit enter, and now you can see that hatch pattern has become more dense. Hit escape, that's now complete. And finally, the earth hatch. So hatch, click, escape. Now we're ready for our earth hatch. So I'll click on this, go to my drop down box, find earth, there it is there. At the moment, it's extremely small, as you can see as you zoom in on it. So we'll make this bigger. So I'll make the size maybe 15. Maybe a little bit bigger, 18. And I'll turn the angle to 45 degrees. And the transparency, I'll make 50. All right. Now, finally, I'm going to make one more layer, which is going to be a pen 70. So this is the thickest line weight that we end up using in this project. And I'll make that like a purple layer. And again, a line weight of 0.7. And I'm just going to draw one line from one end of the ground to the other end. Make sure it's on the right layer. And then delete the polyline that I used to create the earth hatch. Okay, it looks much neater that way, that's fine. But I will keep these lines around here to define these zones. All right, so that's complete. The last thing to do is to go back to my reference planes and think about where we're going to have the window and how that's going to work, because that's going to carry on to the elevations. So what I'll do is I'm going to go back to the drawing, Now, typically, we dimension things from the finished floor line, and there are pretty typical heights for certain heights of ceiling. So as an example, this is a 2.4 ceiling. So doors and windows generally sit, the head of them, so the top of them generally sit at 2.1 meters above the finished floor level. So we're going to take this ground line and we're going to offset this 2.1 meters. That gives us this head height for the window. And then in this instance, you would then choose your manufacturer of window to get the depth or the height of that window, and you would take it from the head height downwards. So in this instance, this line would be offset 1,150. And of course, with the door, you don't have to worry because it's going all the way from the finished floor level up to that head height. If this was a 2.6 or a 2.7 ceiling, you may still have a 2100 high door, but you may have a 2340 door. If you've got a 4 meter ceiling, you will probably more likely have a 2500 or a 2600 door. It's usually architecturally driven. Although, of course, if we're working in a commercial space, then there are minimum head height requirements that we need to comply with the relevant codes. So go back to CAD. I'll take this reference plane and I'll offset it 2100. So that's the head of our window. And then I'll offset that line downwards 1150. And now this is the zone that you can put your window in. So the window will be drawn just like any other block. So you must block it, and it must be on the A window 18 layer. Must be on the right layer. You'll then see the details for how the lintel and the head stud and the bottom sill stud are inserted. And you'll also note there's a stud in the center of this wall as well, just a typical nogging. So that will then conclude how we create our section. So I'll turn those reference planes off. That would then complete this section. And then from here, we'll convert this section into elevations. So now we're completed with the section. We're going to turn the section into elevations, and that is the standard way that you would document buildings. The floor plans inform you of your sections, and then the sections inform you of your facade treatment or elevations. It's very rare that it's the other way around. Now, you can always design a building with a facade in mind, and you can sketch facades, and that's extremely common. But when it comes to actually documenting those buildings, those projects, you really need to firstly ascertain, what is your subfloor structure, what does your roof structure look like, because that will then tell you about, what is your building envelope zone and how you're going to clad that. So the first elevation we'll start with will be what specifies the east elevation or the front elevation. So let's go into CAD, and I'm going to take this group and I'm going to copy this across. And I'm going to rotate this back around in the original orientation. I'll then move this group down. Doesn't really matter where. Okay, and we're going to continue on with all these guidelines. A lot of this has to do with guide or reference planes. So I'm just going to draw a line randomly out here in the middle of nowhere. And then I'm going to use the extend command. And then extend these lines out to that zone. All right, so let's keep going. We've got, as we've done with before, we've got our guidelines here. We have our external wall faces. We then have the eave line. Okay. We also have the top of our roof because that's now defined because of the section. Okay, and we also have two extra lines here, one that denotes the top and the bottom of the fascia board. So this might get a little bit confusing, but because you end up with a lot of lines. And one here. All right, so we then need our door opening, which we've already got sketched here. And then finally, the window. So we're defining where the window is in elevation. We already have its associated heights because we drew that from the section. So we've got, here's the bottom of the window, and here's the top of the window, and the window is sitting within this zone here. So this may not look like a lot, but we actually have defined most of the elevation already. So using pen 18, I'm going to go around just using the box tool and just start sketching this out. So I know my roof is from here to there. I know my fascia board is from here to there. I know my walls are from this point all the way down to the ground. I know my door is from here to there, and I know my window is from this point to this point. Now, it still may not look like a lot, but if I turn the reference planes off, you'll see we've defined that front elevation relatively quickly. Okay. Now, of course, I need to make sure that I draw my windows and doors on the correct layer. And there's just a couple of more lines that we need to take into account. Firstly would be the stairs. We need to draw the stairs in elevation. Secondly is the ridge capping material. So the hatching for the roof doesn't go all the way to the top of the roof. You'll see that in the example set. You'll see here, there's like a line where there is no material. And the reason for that is because that is like the actual ridge capping of the roof. If I go to the detail, you'll see here's the ridge cap, and this material here sits over the top of that. So when we look at this in elevation, we're seeing that line, and then you're seeing the roof sheeting underneath. And then we also have the lines for the gutter. You can see there and there. Okay. So going back to CAD, I'm going to use a pen 9. And I'm going to start at the top here and just come down 50 mil. And then across. The gutter I'm going to leave for now because we're going to detail that up in a little bit. But I am going to switch these to the correct layer. So this needs to go on the door layer, a door 18. And this needs to go on the correct window layer. Now, in terms of making these into blocks, again, the window is very easy. The door, I'll leave to you guys. I'm sure you know how to do that. As for the window, some of the dimensions to take note of is I'm going to take this window, offset it 35 mil, offset it internally again, another 25 mil. I'll take a line and go through the center of the window from there to there. And then offset that 20 mil up, 20 mil down for the sash. And then finally those arrows I'm going to go from this point here. I'm going to draw down, say 150 mil. And then on a 30-degree angle, I'm going to draw 150. I'll mirror that. And then delete that. And then I'll take that whole item and mirror it halfway from the window to the other side. Then I'll select all of these lines and make sure that they're all on the correct layer. Okay, so that's my window done. And then I can go ahead and block this as you normally do. The door I'll leave for you guys. You know that there's a 50 mil door frame around the outside, and then the rest of it's pretty self-explanatory. Going back to pen 9, I'm going to just do something for the stairs. So the stairs will go like so. And then what is that height? That's too high. So we need to divide this up into 3. So a distance from here to here is 460. So we need 153 mil high stairs. So I'll just take one line here, draw across, and then offset 153 down, and then again 153. I'll move that. So that's our stairs in elevation. Lastly, we've got to add the hatching for our elevation. So again, I'll make sure that I'm on the correct layer, which is AN hatch. And then we'll go hatch once for the building, hit escape. I'll then click on that and I'll change this just back to our diagonal lines we were using before, but this time I'll rotate the lines 45 degrees so they're straight, but we need them to go actually 90 degrees, so it'll be 135 degrees. We'll make these straight lines. And then I will make them 50% transparent and the gap between them a little bit bigger. There we go, 50, a scale of 50. That looks about right. And then again, hatch for the roof, click. I'll use that same hatch again. This time I will rotate it 45 degrees, so that way it's directly up and down for our tin roof. Make sure it's got a transparency of around 50 and a scale probably of around, 20. Looks good. Okay, so that's one elevation. And then finally, you've got the thick ground line, which is a pen 70, which I'll just run from one side, randomly from one side of the building to the other, generically. Okay. Now the same thing can happen again. I mean, you can take this elevation and basically copy it across, and all you need to do is delete the window, delete the hatch, delete the window, delete the door, and then rehatch it, and then you immediately have your back elevation. And then as for your left and right elevation, you could trace the section and copy that across, at least just the outside, just to make sure you've got like the ridge and the roof line right. And then again, you already have this information, if I rotate that 90 degrees, of where the window is, because it's defined in the floor plan. And you have the height because it's already defined here. And because this window should be a block, you should just be able to, pick this up and then just move it to the other elevation.